Alright, so in this problem, I have 8 to the power of x is equal to 16. So I want to find the value of x here. So for my solution, I'm going to start by rewriting my equation here. So my equation is 8 to the power of x is equal to 16. Now, before we start doing anything, let's just inspect this problem real quick. So if I plug in x equals 1 into this equation, I get 8 to the power of 1 is equal to 16, which 8 to the power of 1 is the same thing as 8, so I get 8 equals 16, which is false, right? Now if I plug in x equals 2, I get 8 to the power of 2 is equal to 16, and 8 to the power of 2 is 64. So I get 64 equals 16. And notice how there's a big gap between 8 and 64. So we know that the value of x is not going to be a whole number but a decimal, and it's going to be somewhere in between 1 and 2. So x is greater than 1 but less than 2. We know this. Now, how are we going to actually solve this problem and find the exact value of x? Well, what I can do is rewrite 16 as 8 times 2. Now what I'm going to do is divide both sides by 8. So then these two cancel out, and I get 8 to the power of x over 8 is equal to 2. Now if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So a to the power of x over a to the power of 1 is equal to a to the power of x minus 1, which is equal to 2. Now a is the same thing as 2 to the power of 3, so I get 2 to the power of 3 to the power of x minus 1 is equal to 2. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 3 to the power of x minus 1 is the same thing as 2 to the power of 3 times x minus 1. And 3 times x minus 1, I can distribute 3, so I get 2 to the power of 3x minus 3 is equal to 2. And 2 is the same thing as 2 to the power of 1. And if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So this means that 3x minus 3 is equal to 1. And now if I add 3 on both sides, I get 3x is equal to 4, and x is equal to 4 over 3. Now, there actually is another way to solve this problem. What I can also do is at the start rewrite both of these in bases of 2. So 8 is the same thing as 2 to the power of 3, so I get 2 to the power of 3 to the power of x, and 16 is the same thing as 2 to the power of 4. Now this is the same thing as 2 to the power of 3x is equal to 2 to the power of 4, meaning that 3x is equal to 4, and x is equal to 4 over 3. So this is a much simpler method of solving this problem. Alright, so in this video, I'm going to solve the problem 15 to the power of 50 over 3 to the power of 25. So to solve this, I'm going to first start by rewriting this as 15 to the power of 25 plus 25. So I rewrote 50 as 25 plus 25 over 3 to the power of 25. And the reason I did this is because now I can use the property a to the power of m plus n is equal to a to the power of m times a to the power of n. So in this case, 15 to the power of 25 plus 25 is going to equal 15 to the power of 25 times 15 to the power of 25. And I have this over 3 to the power of 25. And now this is equal to 15 to the power of 25 times 15 to the power of 25
over 3 to the power of 25, which is equal to 15 to the power of 25 times 15 over 3 to the power of 25. And this is equal to 15 to the power of 25 times 5 to the power of 25. Now, another property of exponents is that if I have something from a to the power of m times b to the power of m, this is equal to a times b to the power of m. So this is going to equal 15 times 5 to the power of 25, which is equal to 75 to the power of 25. So this is my answer.